Hello friends, again here Netcons Tejada. In this tutorial I'm gonna explain you the functionality of the master boot record. When you turn on your PC, the processor attempts to begin the process of processing data. But since the system memory is empty, the processor doesn't really have anything to execute or even begin to know where to look for it. To ensure that the PC will always boot regardless of the BIOS code, both chips and BIOS manufacturers developed their code so that the processor, once started, always starts executing at the same place, FFF08. Similarly, every hard disk must have a consistent starting point where key information is stored about the disk, such as the number of partitions and what type they are. There are also must be some place where the BIOS can load the initial boot program that starts the process of loading the operating system. The place where this information is stored is called the master boot record, also referred to as the master boot sector or even just the boot sector. Do not confuse the master boot sector with volume boot sectors, which are indeed different. The master boot record is always located at cylinder 0, head 0, and sector number 1, the first sector on the disk. This is the consistent starting point that the disk will always use. When a computer starts and the BIOS boots the machine, it will always look at the first sector for instructions and information on how to proceed with the boot process and load the operating system. The master boot record contains the following structures. Number 1, master partition table. This small bit of code that is referred to as a table contains a complete description of the partitions that are contained on the hard disk. When the developer designed the size of the master partition table, they left just enough room for the description of 4 partitions, hence the 4 partitions for physical partitions limit. For this reason and no other, a hard disk may only have 4 true partitions, also called primary or physical partitions. Any additional partitions must be logical partitions that are linked to one of the primary partitions. One of these partitions is marked as active, indicating that it is the one that the computer should use to continue the boot process. Second, master boot code. The master boot code record is the small bit of computer code that the BIOS loads and executes to start the boot process. This code, when fully executed, transfers control to the boot program stored on the boot partition to load the operating system. Obviously, due to the great importance of the information stored in the master boot record, should it become damaged or corrupted in some way, serious data loss often occurs. The master boot code is the first program executed when you turn on your PC. Remember that. And is often the target of a virus. In order to understand the master boot record and the master boot code buried within it, it might be helpful to understand the sequence of events that occur when your computer starts. Although often overlooked as a diagnostic tool, the boot sequence performed by your computer can often tell you that may be wrong with the hardware itself should you be experiencing problems, even moderate ones. The following will take you through the system boot sequence step by step. If you notice anything unusual through each sequence of events, then you only need to look at the step where the delay appears to occur or back one step. What occurs during the system boot sequence? The system BIOS, a small bit of code inserted in the BIOS from chip located on your computer's motherboard, is what starts the computer running when you turn it on. Below we have outlined the typical sequence of events that occur during your computer's startup process. Although they will vary by the manufacturer of your hardware, BIOS, and the peripherals you have in the PC. Again, this is a typical sequence of events that occur when you turn on your computer's power switch. The first thing that happens, the internal power supply turns on, initializes, and then takes a few moments to generate reliable power for the rest of the computer. If the power received by the motherboard's chipset and subsequently the processor is not within expected parameters, the chipset will generate a reset signal to the processor in the same fashion as if you were to touch the reset button. This will continue until the motherboard receives a power good signal from the power supply, or you turn the system off because of a failed power supply. Number 2, after the power good signal is received, or after the reset button is released, and there is confirmation of reliable power, the processor will be ready to start executing. When the processor first starts, it really has no idea what to do next, as there is nothing at all in the memory to execute. Of course, the processor designers are aware of this, so they pre-program the processor to always look at the same place in the system. What is that? The BIOS ROM, the BIOS read-only memory, for the small bit of startup code to begin the boot process. There is typically located at memory location FFFF08, or right at the end of the system memory. Developers located there in the event, the size of the ROM has to be changed so as to prevent compatibility problems. Since there are only 16 bytes from there to the end of the conventional memory area, this location contains just a jump instruction telling the processor where to go to find the real BIOS startup program. The BIOS performs the power on self test. Number 3, the BIOS performs the power on self test, the POS. If there are any fatal errors, the boot process stops. If the POS is successful, the BIOS calls INT19, interruption number 19, and then proceeds to look for devices attached to the motherboard. Number 4, the BIOS code begins its search by looking for the video card. More particularly, it's looking for the video card's built-in BIOS program, normally found at location Charlie 00 Hector in memory, and if found, runs it. The system BIOS executes the video card BIOS, which in turn initializes the video card. Most modern video cards will display information on the screen about the video card, which is why on some modern PCs you usually see something on the screen about the video card before you see the message from the system BIOS itself. Number 5, once video has been enabled, the BIOS begins searching for other devices that may have their own read-only memory and whether that read-only memory has its own BIOS code. Normally, the floppy drive is located at 00007 Charlie 00, and the IDE 8 hard disk BIOS will found at Charlie 8000 Hector. If a floppy and or hard drive is found, their codes are executed. If during this interruption 19 process any other device BIOS are found, they are executed as well. Number 6, the BIOS display is a startup screen which provides some key information about the BIOS as well as other system information. Number 7, as the boot sequence continues, the BIOS continues to perform additional tests on the system. Depending upon the system manufacturer, this will usually include a memory count. The BIOS will generally display an error message on the screen if it encounters an error when it can installed memory. You will find this error message and explanation in our support center in the motherboard and BIOS section. Number 8. During the next phase of the BIOS startup process, it performs somewhat of an inventory of the hardware installed in the system, and then communicates or interrogates to ensure that the hardware is functioning. Most modern BIOS have automatic settings to collect information such as memory timing, based on what kind of memory it finds. Based on what kind of memory it finds. Today's BIOS dynamically set hard drive parameters and access modes Today's BIOS dynamically set hard drive parameters and access modes and will display a message on the screen for each drive they detect and configure in this way. It will also search for label logic devices such as COM and LPT ports. Note: if the BIOS supports the plug-and-play standard and the feature is enabled, there is the point at which will detect and configure plug-and-play devices and display a message on the screen for each one found. Number 9. During the final phase of the BIOS and BIOS boot process, the BIOS will display a summary screen with your system's configuration. While early machines 4A6 through Pentium number 2 were fairly accurate about the system configuration information, later machines using the later Pentium number 3 and AMD processors can have some inaccurate information. This is usually related to BIOS setup usages involving processor information. Checking this data can be helpful in diagnosing setup problems, although it can be hard to see because sometimes it flashes on the screen and then scrolls off the top. Number 10. Once the BIOS finishes what it needs to do, it begins searching for a drive to boot an operating system. All BIOS contain a setting that controls the search sequence for a boot drive. Most are set to first look for a bootable floppy disk, and if one is not found, then proceed to a hard disk, which is usually the C drive. Some BIOS permit you to boot from your CD-ROM drive or other device such as small computer system interface, depending on the boot sequence selected. Once the BIOS identifies its target boot drive and looks for boot information to start the operating system boot process. If it's searching a hard disk, it looks for a master boot record at cylinder 0, head 0, and sector 1, the first sector and the disk. If it's searching a floppy disk, it looks at the same address and the floppy disk for a volume boot sector. 11. Once the boot sector is found and its contents of data verified, the BIOS starts the process of booting the operating system by using the information in the boot sector. In this is floppy disk boot sector. If this is a floppy disk boot sector, the information is read into memory at location 0007 Charlie 00, interruption 19 goes to memory location 0007 Charlie 00 to continue the process. If no boot sector is found on the floppy drive, interruption number 19 moves to the next bootable drive in the list provided by the motherboard BIOS, usually a hard drive, and then attempts to read the master boot record. If a master boot record is found, it is read into memory at location 0007 Charlie 00, and the interruption 19 jumps to memory location 0007 Charlie 00, the same as was the case with the floppy. At this point, the BIOS attempts to move control of the computer from the BIOS to the actual operating system. Next, the small program in the master boot record will attempt to locate an object partition in the hard drive's partition table. If such a partition is found, the boot sector of that partition is also read into memory at location 0007 Charlie 00. and then the master boot record program itself jumps to memory location 0007 Charlie 00. Keep in mind that each operating system has its own boot sector format. The next step involves the small program and the boot sector located in the first part of the operating system kernel loader program, or in some cases at the kernel itself, or perhaps a boot manager program, and read then that into memory. 12. If no boot devices of any type can be found, the system will display an error message and stop. The specific error message depends on the BIOS developer or on the computer's manufacturer and can be anything from a rather clear no boot device to very encrypted, no ROM basis system halted. This will also happen if you have a bootable hard disk partition but forget to see it active. Believe it or not, you can partition a drive, format it, and install the operating system and never realize that there is a problem until the first start on the operating system occurs. This entire process is referred to as a cold boot, since the machine was soft or cold when it started. A warm boot, also known as a soft boot, is the same thing as setup goes when the machine is rebooted using the Control-Alt-Delete keys. In this case, the post is kept and the boot process continues as roughly step 8 above. As a side note, interruption netting also called when the Control-Alt-Delete keys are used. On most systems, Control-Alt-Delete causes a soft boot or shortened version of the post to be executed before interruption netting is called. Many dents can damage the master boot record, therefore it might be helpful for you to know where certain portions of the code reside in the master boot record should you have to recover master boot record manually. You will find that the master boot record program code starts at offset 0000. The master boot record message starts on offset 008 Bravo. The partition table starts at offset 01 Bravo Echo, and the signature is offset 101 Foxtrot Echo. Summary: if an active partition is found, regardless of where it's found, that partition's boot record is read into memory at 00007 Charlie 00, and then the master boot record code is added to 00007 Charlie 00, pointing to the partition table entry that describes the partition being booted. The boot record program uses this data to determine the drive being booted from and the exact location of the partition on the disk. If no other partition table entry can be found, the boot process enters ROM basis via interruption 18. All other errors will cause the system to hang or stop. Notes, extremely important. 1. The first byte of an active partition table entry is 80. A0. This byte is loaded into dynamic library register before interruption 13 is called to read the boot sector. When interruption 13 is called, dynamic library is the BIOS device number, or DL, is the BIOS device number. Because of this, the boot sector read by this, because of the boot sector read by the memory boot record program can only be read from BIOS device number 80. This is one of the reasons why it is usually not possible to boot from any other hard disk. Of course, where there are exceptions to every rule, but those are beyond the scope of this exercise. The master boot record program uses CHS-based interruption 13H AH02H call to read to boot sector of the active partition. The location of the active partition boot sectors in the partition table entry in CHS format. If the drive is 528 MB, 528 megabytes, this C8S must be translated CHS. No addresses in LBA firm are used. When disassembled the master boot record, this sector is initially loaded into memory 00070 Charlie 00, but immediately relocates itself to 0000600. Okay, fellas, thank you very much for the time being. Remember that we provide tech support 24 hours a day. Don't hesitate and give us a call in order 24 hours. Don't hesitate to give us a call at the number 809-977-7941, and we provide tech support via WhatsApp. Thank you very much, and don't forget to give us a thumbs up at the end of this video clip. See you next time. Bye-bye.